But now let's move on to our next topic, our greatest common factor. We've got a couple of new vocab terms here. So monomial, that's an expression of one term that consists of a number, variable, or a product of a number or variable and variable. So that could be something like 5x or 6y, just one number, a variable, or their product, just one grouping of terms there. That's our monomial. Then our greatest common factor, or our GCF, which is the biggest factor that evenly divides a set of monomials. The GCF is used in factoring. Then we're asked to find or create a factor tree for the numbers 8 and 20. So with our factor tree, we start off with our original number, and we're just trying to break them down into all of its prime factors. So 8 we can say is 2 times 4, and 4 can be broken down to 2 and 2. We're stopping at these 2's because 2 is already prime, so we don't need to break that down any further, and we're done with our factor tree for 8. Similarly, with 20, we can break that down into 4 times 5, and you can pick any two pairs of factors you want. I could have done 2 and 10 there, but I just picked 4 and 5. You'll get the same final answers regardless. 4 can become 2 and 2, and then 5, we're done there because 5 is prime, so our two factor trees are set. Now we're being asked to find the greatest common factor of the following two numbers, and then we have two pairs of two numbers. So let's try letter A together. Best way to do these is, well, to make a factor tree. That's why we just did one, to get a little bit of a refresher on those. So with 36, we can break that down into 4 and 9, which becomes 2, 2, 3, and 3. 45, we can break this one down into 5 times 9. 5 is prime, but 9 is not, so we'll break that into 3 and 3. And our greatest common factor, we want to look for, well, what prime factors do they have in common? So here we've got 2 3's, and here we've got 2 3's. This one has some 2's, this doesn't contain any 2's, and this one has a 5, but our 36 has no 5's in it. So all they share in common are these 2 3's. So then to finally find our greatest common factor, we just want to multiply all of their common factors together, which would be 3 times 3, giving us 9. Alright, why don't you go ahead and pause the video again, see if you can work on letter B, and figure out how to do that one on your own. Okay, so let's go over this one together. 39, we'll break that, or we'll use a factor tree to break that apart into 3 times 13. And then 18, let's see, we've got 18 can become 3 times 6, and 6 is equal to 2 times 3. So it looks like they only have one 3 in common here. That'll give us our greatest common factor, nice and easy, just a single 3. Alright, let's take a look at some monomial terms with actual variables in them this time. So now we've got 46y squared and 28xy. Well, we can actually make a factor tree with our variables too. We could say this is equal to 46 times y squared, and 46 can become 2 and 23. Y squared becomes y times y. Now let's try the same thing with our 28xy. Well, that's equal to 28xy, which is equal to 2 times 14 for our 28, and our xy can be split apart into x times y. So now let's see, well, what do they share in common? It looks like we've got a 2 and a y that come up in both of these. Oh, I needed to break my 14 down again. 14 is 2 times 7. But that still doesn't change our greatest common factor. They only have one 2 in common and one y in common, which will give us our GCF of 2y. Okay, now try out B again on your own, see what you can do, and we'll get back and go over it together. Alright, so same thing here. We can make some more factor trees together. 36x squared and y squared. I'm just going to do 3 branches this time. We'll get 36 x squared, y squared. Then we can say 36 is the same thing as 4 times 9, which breaks into 2, 2, 3, and 3. X squared becomes x times x, and y squared becomes y times y. Same thing with our 20. Y to the 4th, break that into 20 times y to the 4th. 20 can be represented as 4 times 5, and our 4 can be broken down into 2 2's. Our y to the 4th, we can say, is y squared times y squared. We'll break that down into the 4 separate y's. So now let's see, what do we have in common? We've got 2 2's here, and 2 2's over here. We have no 3's in common, no x's in common, but it does look like we have 2 y's in common. So all together, we'll get 2 times y, which is going to give us 4y squared. Okay, a couple more problems for this page. We've got a couple of word problems to go over. What is the greatest common factor of 18 and 48? Explain your answer, and then we're given a couple of explanation choices to choose from. We've got 66 is because it's the sum of the two numbers, and 30 because it's the difference between the two numbers. But we're not worried about sums or differences. We're trying to find factors here, so we can disregard those two. 9 because it divides evenly into 18. Well, that's only concerning 18. We want to look at both of these numbers together. And then 6 because it's the largest number that divides evenly into 18 and 48. Well, that's the exact definition of our greatest common factor, so D is going to be our right choice here. Now, which expression uses the GCF and distributive property to find 16, or to properly find 16 plus 40? Well, if we find the GCF between these two numbers, we're going to get our GCF is equal to 8. So if we have 16 plus 40, and we're trying to factor out an 8 from that, that's going to give us 8 times 2 plus 5. All we did was pull out an 8 from each of those two terms. Then if we're using our distributive property, we're distributing that 8 into both of those individually here. So we get 8 times 2 plus 8 times 5, which is letter choice C. Okay, let's do one more for this page. We've got Kevin has 24 magazines and 56 books. He would like to place the same number of magazines and books on each shelf in his bookcase. What is the greatest number of shelves he will be able to fill if he uses all of his magazines and books? Well, this is just asking us to find our greatest common factor between our magazines and our books to see how many shelves we can fill. So if we break down these two numbers into their GCFs again, or into their prime factors again, let's see, we'll get 3 times 8. And 8 we can say is 2 times 2 times 2. Then for our 56, we can say that is 7 times 8. 8 again is the 2 times 2 times 2. So it looks like they have that 8 in common, are 3 factors of 2. They don't share any 7s or 3s in common. So greatest common factor between these two is just going to be our 8, giving us that right final answer. One more little detail I'd like to point out. So that's the number of shelves they'll build, and each of those shelves will have 3 magazines and 7 books on those shelves.